All right, welcome back to pre-calculus. We are going to continue talking about inverse trig functions, and we got a good one here. This is the kind of problem I would ask. It's another good example of it. So let's see if we can set this up. All right, so we have a tangent of the inverse cosine of negative 7/8. So we have the tangent of negative, no, not the inverse tangent. We have a tangent of the cosine of inverse of negative 7/8. Okay, let's put some parentheses in here so we can see what we're doing here. Okay, what is the inverse cosine going to give us? Right, remember that the inverse cosine theta equals the inverse cosine of some kind of a ratio. Okay, and that's going to be in quadrant 1 or quadrant 2. So we're going to end up with some kind of a angle over here somewhere. Okay, since it's going to be negative, it's going to be in quadrant 2. Okay, so we're just going to get the inverse cosine of negative 7/8. If I go ahead and do that, I could do it in degrees. Okay, so I think just double check my mode. My mode is in degrees. It sure is. It's right there, second function degrees. So we'll quit that. So we'll just say inverse cosine, okay, of negative 7/8. So not negative, not this one. You have to use this one. Negative 7 divided by 8. Okay, and in degrees, it is 151. How many decimals do they want? Okay. I don't want the exact answer. I don't think this is an angle we're supposed to know. Hmm. Oh, okay. Let's do it that way. So there's going to be negative 7/8. Okay. So I know that okay. Let's draw a triangle because that's always the trick of solving a trig problem that you're stuck on. It's like, did you draw the triangle? Not yet. Like, well, let's draw the triangle. So we want theta is equal to the inverse cosine of 7/8, negative 7/8. So if I take the cosine of both sides, cosine of theta is equal to negative 7/8. Now, you have to remember what cosine is. Remember, cosine is adjacent over the hypotenuse. So what do we draw for that? That's going to be 7, right? Because we want negative 7. And then the hypotenuse is always 8. So we have to figure out, because eventually we're going to want the tangent of this thing, right? The tangent's going to be the opposite over the adjacent. So we're going to need this side here, right? So this is 8. Let's go 4, but let's make it look like an 8. So in order to figure out this last remaining side, we're going to say, oh, well, this is a squared plus b squared must be c squared. So we say b squared is equal to c squared minus a squared. Okay, I always make a the adjacent side just for the sake of it. C is always the hypotenuse. So we have b squared is equal to c squared. That's 8 squared minus a negative 7 squared. Okay, so we're going to have 64 minus 49. I'm not doing that in my head. Okay, so we use a calculator to help us out a little bit. It'd be like 34-ish kind of a thing, 24-ish. So that's why it doesn't do it in his head. So you're right. 64 minus 49. Okay, 15. Okay, that sounds good. 64 minus 49 is 15. So b squared, so I was way off, is 15. Okay, so b is equal to the square root of 15. Square root of 15. Remember, this adjacent side is still negative 7 because we're talking about this angle here. And then what's the tangent of this angle? It's technically what's the tangent of this angle as well, right? We're just looking at a reference angle. So the tangent of our theta is equal to the opposite, right? Is equal to the, I'm sorry, not a 7, is equal to the root 15 over minus 7. And that's going to be our answer. What do they want rationalized? They want the exact value. Simplified fashion, rationalize the denominator. So all we're going to do is say, well, okay, that's fine. 15 doesn't have a nice square root to it, so we're just going to say root 15 over, I think it's 8 over 7. Okay. And we're just going to put the negative sign out front because that's where I like to put it. Okay. And that's how we're going to go ahead and get that. So let's check and then we'll see how we're doing. Okay. That's exactly, I mean, this is another kind of a problem that I would have you guys do for a quiz. This is a really good example. So if you're looking for like kind of things that you're going to ask, this would be it. Okay. The previous problem is also good. So thank you for tuning in and I will see you in the next video.